Hello guys, today we will be solving the Leetcode question number 797. All paths from source to target. First let's read the question. Given a directed acyclic graph of n nodes labeled from 0 to n minus 1, find all possible paths from node 0 to node n minus 1 and return them in any order. The graph is given as follows. Graph of I is a list of all nodes we can visit from node I. So here you can see the example one. They are given a one directed acyclic graph. So we have to find possible paths between from 0 to starting node to end of the node. That means number of nodes. First we have to count the number of nodes. There are 4 nodes, the first node and the last node. We have to return the total number of possible paths from first to last. So first we will see how to count the possible paths. Then later we will see how to store the path values in the array. So here you can see this is the given array 1 comma 2 comma 3 comma 3 and empty. So from 0 either we can go to 1 or either we can go to 2. From 2 we can go to 3 and from 1 also we can go to 3. So we have reached to the end, 2 3s. So this is the one path and this is the another path. So total 2 paths. Now let's see one more example. So from 0 we can go to 1 or we can go to 4 or we can go to 3, and again from 1 you can go to 3 or 2. So 4 is the end, and from 1 we can go to 4 also. From 4 we are done. From 3 we can go to 4, again here 3 can go to 4, 2 again 3, 3 to 4. Can say one path, one possible path, 2, 3, 4, 5. So 5 possible paths are there in the second graph. Now let's see how to store the paths, how to like moving further, how to store in the temporary array or any array. That all paths we need to return back to the main function. Now we will see how to store, how to save the paths. So first we will see for the small graph. So first we will take the first node 0. So here we have 0 to 3. Total 4 nodes are there in the first graph. So in this array, take the last element. So this is 0. So check this 0 in this array. So 0 is 1 comma 2. So what you have to do is take each element from this and put it in the one element in, like, created duplicate paths 0 comma 1 and 0 comma 2. So from 0 we went to 0 first position as well as the second position. Now in this array the last element is 1. In this array last element is 2. So here 1 means 3, here 2 means 3. So now append that new node to the old path. So 0 1 3. Here also you have to append it 0 2 3. So now the last element is 3. Here also last element is 3. So 3 is the final node. So you don't need to move further. You can store these both arrays and return back. Now we will see for the big graph also. So we start from 0. So the last element is 0. So 0, 4 is 4, 3, 1. We got that array by the index. So take out each element and append it to the original array. 0, 4, 0, 3, 0, 1. So here 4 is the last element, here 3 is the last element, here 1 is the last element. Now 4, here you don't need to move further, you already reached to the end. So from here 3 is 4, so 0, 3, comma 4. So you're done, you don't need to move further, you reach it to the end. So now this one 0, 1, so 1 have 3, 2, 4. So to create 3 separate paths, 0, 1, 3, 0, 1, 2, 0, 1, 4. So here the last element is 3 in the array. Last element is 3, here 2, here 4. Here you don't need to move further. So this will become 0, 1, 3, 4. Done. Now 0, 1, 2, last element is 2. Here the 2 index have the 3, only 3. So 0, 1, 2, 3. Last element is 3. So here 3, in the 3 index we have only 4. So 0, 1, 2, 3, 4. You can see you can go to 0 to 1, 1 to 2, 2 to 3, 3 to 4. So finally how many paths we got? 1, 2, 3, 4, 5. Total 5 paths we got. You can see 1, 2, 3, 4, 5. Yeah, total 5 paths. Now let's write code in Python. So first I'm going to capture the length of the graph -1. Now creating one empty array to store all the required paths. Let's write the main function dfs. Here I'm passing the one temporary array. If the last element in the temp array is equal to n, that means the last element in the path is equal to the final node in the graph. In that case we need to store that path, so I'm appending that path to the result. Okay, let's keep it path. It's easy to else we take out each element from the original given graph prefix that we got the array from this list, from this information. We look for the index of path of -1 in this graph, and we take out each element and add it to the path. And again we recursively call this DFS method. So for in graph of path of -1, DFS of temp plus, yeah, add the new element to the existing path, so not temp, path plus I. So here we call the function. So first we start with the 0 node, so passing the first path as a 0. So finally return the result. Now let's write code in Java. So first we need to create one empty result that we store all the paths like what we did earlier before. So for that list integer, so list of list integer result equal to new array list. We created one empty result list of list. Now we have to create again path also, list of integer path equal to new array list. So here we first add the element to the path. So 0 is added, the first node in the graph. Now we are supposed to create one DFS function. Let's start writing the DFS function. Private void DFS. So we'll be taking the graph as well as the starting position of the node, as well as list of list to store the result. And finally path, single list. Path. So if that node equal to graph dot length of -1, now we will store the existing path into the result dot add new array list integer of path. Just return it. Else you need to take each element from the graph and append it to the current path. So for int node of current node element that we are having, and next you need to add to the existing path dot add n. Again you need to recursively call the DFS method to find all possible paths. Graph, then the new node, current node, and the result and the path. And finally you need to remove the currently added element into the path. Make sure in Python we did it in different way, in Java we did it in different way, because there are some constraints that depends on the language. So in Python also sometimes we remove the element after DFS that we use to do a lot in the graph problems. So just get to know why we are removing these things, because we don't want to recalculate again. So that's why we remove already cross-checked the current element. So remove path dot size of -1. So here we call this function DFS graph. So starting node is 0, result on the path. So finally return the result. So that's it for this video guys. We will see you in the next video. Thank you.